Hello everyone. The first topic that we will be learning in the course is about the periodic table. Now, the periodic table, you can call it a blueprint or maybe an ocean, as a great deal of information is hidden or can be dug out from the periodic table. Because if you think about it, as we get more and more comfortable and at the same time more and more complex with the material throughout the course, you may not be able to memorize and be able to do everything, quickly. And that's where the periodic table comes in. Okay. In a nutshell, the periodic table is a foundational block. Okay. It helps you troubleshoot whenever you run into a roadblock. And having a good understanding of the periodic table can help you understand chemistry better because, as I said, the periodic table is the simplest form of chemistry that you can learn. So, without further delay, here is a periodic table. I want you to take a closer look at it because this is exactly the periodic table we will be using for the rest of the class. Now, I would also be posting the same periodic table under resources on our course site, which is Moodle, but then all practice exams and tests and anywhere you're required to use a periodic table, you would use this one. Okay. Why I say that, I will get to it as we actually learn about the periodic table. Okay, there are different versions of periodic table. Even though there's only a set format, there is quite a number of versions that people have created, and you can Google periodic table and go to Google Images. There's just so many things going on. Okay, it's become more artistic work for a lot of people. So we're going to keep it simple, and this is a basic periodic table. Okay, but first let's understand. We're not going to be caught up in the information that's just going to present on the screen for you. But this is something that you do need to remember for the long run. All right, so let's understand the broader categories or umbrellas under which the elements coexist. You look like they're all there, but they're all coexisting in certain families, okay? And that said, I'm not going to actually do a lot of writing on the screen, just this particular video. But you would see in all other successive videos, there's going to be a lot of writing. Okay, just because this is the introductory video, so there's really no real need to write anything. All right, the first group of elements are called the alkali metals. As you can see, the green runs all the way from lithium down the column. The column is called a group, and row is called a period. Okay. I'll just make that clear. So columns are groups, rows are called periods. So the alkali metals are lithium all the way down to francium. And group 2 column, which is alkaline earth metals. So you have alkali metals, alkaline earth metals. What do they have in common? They're both metals, but they exist under their own family of alkali versus alkaline earth metals. And then you've got your transition metals, which are in the middle of the periodic table, like sandwiched. And these are the metals that impart color to your compound. So if you see a chemical compound that's colored, there's a high chance it's probably from the transition metal family. And then you have these elements that are called metalloids. Means they have properties of both metals and nonmetals, but it is neither metallic nor purely non-metallic, which brings us to another family of elements that are called non-metals. So everything that's in orange that you see, it's taken me a lot of time to put this together. So, it's more easier than some other ways of doing this. So these are non-metals, okay? So they're exactly the opposite of whatever a metal does. A non-metal doesn't do that. And then there's one more family. The penultimate family is the noble gases, which are helium, neon, argon, krypton, xenon, and radon. I think everyone that has never even taken chemistry probably knows about the helium balloon that you get at your dollar store. Keep in mind, it's not hydrogen. Hydrogen is explosive, so don't present a hydrogen balloon to a family member. All right. All right. So the reason it's called noble gases, and or I want to get into it, but it's also known as inert gases for your knowledge. Not that if you care or not, but it's also known as inert gases. And the final family of elements are called the inert transition elements, also lanthanides and actinides. Okay, why do I call inert transition? Is you see these are coming off that little crevice on the transition metal, right? Now you do not have to memorize this because you're in the online environment, and I don't rarely ever quiz you whether an element is transition or alkaline earth metals. I think that's more like 6th grade, okay? We're in college, so we're gonna skip all that, but you do need to know that because when we start talking about bonding, I want you to know whether the metal you have is alkali, alkaline, transition, non-metal, etc., etc. Okay? Without further delay, let's go to slide 2. Now, as I said, the periodic table is a blueprint, or I even call it to an ocean. Well, that is true because what sort of information can we obtain from a periodic table? Well, a lot more, and those are not necessarily just limited to these, but atomic radius, which is the size of an atom, and how does it influence its chemical behavior, ionization energy, electron affinity, chemical reactivity, and bonding, just to name a few. Now, we're not going to get into ionization energy, electron affinity, because when I looked at the higher education standards for nursing, typically we're not focusing on that because I think it's more geared towards engineers and other areas of science. So we're not going to focus on that, but definitely you can get all this information. But I think down the road, the idea of periodic table will be extended to the concepts of chemical reactivity and bonding. And I think the nursing standards particularly focus on D and E versus A, B, and C, whereas other science majors focus on all of them. But for some reason, the nursing people choose to focus D and E. To me, that works. But first, let's learn about an atom. Okay, now this video, I'm going to make all videos less than 10 minutes if possible. Unless it's a complicated concept, then it might be slightly longer. But what is an atom? Now, if you Google the word atom itself, chances are there's going to be a host of definitions and you really don't know which one to follow. Well, neither I am. So I'm going to give you a couple of my view of what an atom is. They're basically the building blocks of matter. If you look at proteins, you look at sugar, you look at enzyme, everything is made up of carbon, hydrogen, and oxygen atoms. Okay, so they're building blocks of matter or fundamental component of matter, in a simple words. But there's probably more tedious definitions on Google on every single website that you hit on it. All right. So what I have done here is, as I mentioned in my introductory welcome video, chemistry is understood better if it can be visually walked through than a mere PowerPoint presentation or simply talking about it. Neither of those does not seem very effective. So I created this visual where I've given different color codes to identify what makes up an atom. An atom is made up of primarily 5 different components. One is the nucleus, it's yellow, orbitals that are blue in color, electrons. Now keep in mind, from now on, electrons are negatively charged, protons are positively charged, and neutrons don't have a charge. So that's what I meant by 5 components. Now here is a broader visual when we put it all together. There we go. Now if you see, your nucleus is at the center. This is called the plum and cake model. If you take a plum cake and you just shave it in the middle and look at it, then this is what you're going to see. You're going to see plums spread everywhere, and you got the strong core of the cake in the middle, which is denser portion of the cake. That's kind of what the nucleus is, and then you got your orbitals surrounding the nucleus. Now, as we go further into the 3rd or 4th series of videos, we are actually going to label these orbitals for a particular element. Okay, each element has a unique set of all of these. Okay, every element in the periodic table has all these 5 components, but how they are set up is what makes each element different. Okay, so the purple color you see is a single atom. Okay, it's not a single element, a single atom inside an element. We're going to also discuss more about atoms during the course of the course, but a single atom contains this setup. So if an element contains so many atoms, each atom contains a duplicate of the material for that particular element. Okay, so you see the nucleus and protons are inside the nucleus. The electrons circle like, the planet, planet circle the sun, so they're orbiting around the nucleus, right? Which brings us to, what are orbitals? Orbitals and atoms are like fish and chips, okay? They go together. Whenever you talk an atom, you cannot just keep talking about orbitals. Or when you talk about orbitals, obviously you're in the vicinity of an atom. Okay, they're called the layers or shells containing the electrons. This is where the electrons are stored. Even though they're not stagnant, they're moving around. Okay, orbitals have specific labels to them. Like I said, we're not going to talk about what are those orbitals and all that stuff in this particular video. This was primarily to introduce you to what an atom is, because at the end of this course, you have an A and a friend of yours asks you, hey, I have a question about what makes an atom, and you cannot answer that question, then the purpose of your A has zero meaning. Okay, you might as well just take an F and just quit the class, because this is so fundamental. And if you cannot answer that fundamental question, then your learning is a big question. So I want to take the time to set you up to that. So we're going to learn all about orbitals and everything in greater detail at every component of the course. Okay, every orbital has a certain amount of energy. Okay, as you get further and further away, that is outer towards away from the nucleus, your energy is going to go up, and the more and more you get closer to the nucleus, the energy is going to go down. Okay, so what I want to do is I want to stop here, because the topic I'm going to press it next is related to this. Again, everything is related, but I want to stop the video here, because what I want to do next is go one step further and actually decode the numbers you find within the box of a periodic table for a particular element. And that's really when we're going to kickstart our discussion into chemistry. All right, so stay tuned for more videos. And this is the very, very first video on the topic. So this is where I want to stop the video. All right, good. Stay tuned.